Everyone, welcome to Con 308 Emerging Technologies. My name is Benwin. Today I'm going to show you my implementation and demo of the uh, supervised learning using artificial neural networks, applying backpropagation through TensorFlow to train and predict the species of iris flower, similarly to the XOR or explosive OR problem that we discussed in class. So by fitting label data such as the SIBO and petal measurement, we train a multi-layer of neural network that learn to classify different type of iris species such as Setosa, Virginica, and Versicolor. So this is the layer of the neural network. The first input, it has 4 features. So four features are such as the SIBO length, the SIBO width, and also the petal length and width, and also the hidden layer with 8. The first hidden layer with 8 neural network, and the second hidden layer with 10 neural network, and the output it has 3 neurons. It stand for 3 output. So what is the 3 output? So these are the 3 output that we use, like 1 0 0, or that one of this one is 1. It has 3 output, and similarly this one also 3 output. By so this is the iris, the JSON file to train. So we pass it through the our model to train of the file of the example reading the SIBO and the petal length and width, and specify it during the train model, and we do it for like the iteration of like 100 epochs. And we have the learning grade is the Adam right here, 0.06, and with the linear or activation function. So to similar like the symbol backdrop, it also during each layer that the weight and the bias are adjusted to provide the best prediction. Or so for this example, like I also added the code to print out the weight and also the bias for each layer. So the first one is the initial, because we have 8, right? So 8 neurons, so that's why you see that it's the 8 number in the first row, and similarly this is 10, and the last one is 3. And also for the bias, so by adjusting the weight and the bias, so the program or the TensorFlow, it can estimate the score. And this application is hacked to park the server to run and train the model, and it also back to the client. I have my application is running, and we implemented using a GitHub. And one of my partner issue, like she have the pop 5000 running on something, and that's why we switch back to like 5001 in order to make application to work for both of us. And so this is 5001. So this is the server. So when I click the server running, so all the training it will log like in my terminal, and then it also has a prediction of the result. Why I see that 3 results? Because in the testing iris testing JSON, we have three objects in here, and it also tested this, and also it have the the correct output, like the species it matching with each one we put in. And this are the training file we use to train the observation. I don't know if I missed anything. Yeah, we covered the way, the adjusted way. And in order to implement it on also the requirement also asks the user can input the features, and also the learning grade, and also the epoch number. So we have a custom server to so that the user they can modify the features, and also modify the number of iterations such as each port and learning grade. We apply it to our default, and we also use the same training file to train, so it may not make big difference or unless we use small number of epoch. And so by using request body, and we pass it to the new model, so I think it's easier to create a model like at the iris data. And in here we have the iris model. It also validate if the iris model is correct or not, and also it also convert the information, and if not passed correctly, we use the default information to the server from our backend. Similarly, it's also the default if the request is missed parameter. and we pass it through. We use the same training with the same model of same layer of neuron, just different number of epochs and different number of what called learning rate, and then we pass the testing data and we predict. We put it on our front end, and we have the application of client is running. All right, also about the routing, it's very important. So this is the default routing. It's like provided by the example by professor, and it's our custom AI, and it also we use as the post method because we get the data from the request body. Moving on with the application. So in here we already have the vibe, configuration with the proxy to the port number with the brown API in here, and for this is the professor code. We just name it the file different like app AI, basically everything from the document, nothing changed. And for my custom AI, we will send the we wait for the user to input the request and we send it to the client, and then when we get the result back, right, it will display the result. And now this is the one we already tested for the server, right? I also display the weight and the bias of each layer after the training. I don't like do it for each iteration. And this is my front end. So this is after I load it, it will try to run the default API of a TensorFlow. So okay, maybe I have to use it HTTP. So it's running the default and it's waiting for the result, and if the result matching, it will have the output. So the matching correctly with what we see in the backend, like right here. So I can do it one more time. I had it, sorry guys. So one more time, and then it's still so. And also we still have the the loss value, and it's not much changing during when it reach the 100 epoch. And now when I go to my custom AI, it doesn't run yet. Why? Because we haven't sent any request. I have the information about the species for testing. So I can use like file right here just to test if my input will have the correct output. Like I will using this information for the length, and then for the width, and for the petal length and petal width, and then this is epoch. So I think it's good practice. When we deal with the form, we let the user know what are accepted value, because training is very important, because if overtraining, it can cause problem with RAM or memory. So we just using display the warning for best performance. I can use 100 or 150 or 125 and learning rate. So it's better to do it like 0.05, and then when I submit it, and it will go to my backend, but you will see the server running with display the epoch and the matrix, also the way, and it's pass it to my client. It's submitted, it's running, and then it's waiting for the result. And now the result is say Virginica, so it match what I input in here. And I also have the probability, like the result probability. This is BC encoding, so nothing special. It's just from the class example. I think we can try it one more time with the Versicolor. Just try it with Versicolor 6, 3.2, and then 4, 1.5. We can use different learning rate such as 0.06, 7, and we use 140 epoch learning. So it's waiting for the result. And now what does it say? Based on my input, so it doesn't have the best probabilities. I don't know why. Maybe because of the it also say Versicolor. Versicolor is the best probability. I think because they have something in common for the Versicolor. Yeah, my input 1.5 right here. So interesting. I haven't tested this one, but when I test the Versicolor, it's 0.08. Wow, interesting. For the Versicolor probability, maybe try again with the Setosa and see the result. I think it's also good, because we just tested one for the 1.5, and here 0.3. The result right now, yeah, Setosa 100%, almost 100%. Interesting response, from a previous response. Let's try it one more time for the Versicolor. Let's do it with 150 import, and then oh, interesting. Yeah, that's the training model. So I think based on what we see, we can adjusting our training model, such as the number of hidden layer, or the neuron in the hidden layer, or the number of iteration. Let's try with like 200 or 250 iteration, and with the learning rate is 0.05, to see if it can enhance the result for the prediction, or if we use higher like import, you see that we have the better result. And I think it's better to give the import at around 250. This is it. And like we can apply this neural learning, or supervised learning, for other application or other problems, such as predict about the probability for certain disease or XOR problem. This is it. Thank you. Bye.